In this lesson, I'll show you how to find the domain of a two-variable function. The first question reads, find the domain of f at x and y, where the equation is sine x plus y minus e to the power of the square root of x plus y squared plus 7xy over x to the power of 3 minus 8y. Think of f at xy as a letter. You can even call it z. So z is equal to the following. But it's in function notation, so we'll just keep it like this. To find the domain of this complex equation, we go term by term. Starting with sine x plus y, we know that anything that you put into sine will give you an output. So any real number that is x or y will give you an output for sine. Therefore, there are no restrictions here. I'll just write down nr. Let's move on to the next term. We have minus e to the power of the square root of x plus y squared. Now we know that with square roots you can't have negative numbers representing the radicand, this part. So x plus y squared needs to be greater or equal to 0. I'll write that down. X plus y squared must be greater or equal to 0. Finally, in our last term, we have 7xy over x to the power of 3 minus 8y. We know that with fractions, the divisor, the denominator in other words, x to the power of 3 minus 8y, cannot equal to 0. So for this, the only restriction will be x to the power of 3 minus 8y cannot equal to 0. Now I want to write down my domain in set builder notation, which looks like this. The domain includes the set of all x and y, and we write that as x, y, such that, this line right here, x and y are members of only real numbers, and then our restrictions. X plus y to the power of 2 must all be greater or equal to 0, and x to the power of 3 minus 8y cannot equal to 0. Now you can also solve for y in both of these terms, although it's not necessary here. Let's move on to question number 2. This time our function is defined as f at xy for the following. Let's start with the first term. We have the square root of y minus x times ln 2x plus y. Now we have two issues here. Y minus x, this radicand, must be greater or equal to 0 for the same reason as discussed in question number 1. So y minus x must be greater or equal to 0. Over here we have ln 2x plus y. 2x plus y must be greater than 0. It can't even be 0. So we have to write 2x plus y must be greater than 0. E to the power of x minus 5y, well, there are no restrictions there. You can place any number, any real number into x and y, and you'll get an output. And the same thing for that last term, 10xy. So if we write the domain in set builder notation, I'll write down D includes the set of all x and y, such that x and y include only real numbers. And this time what I'll do is solve for y in both of these cases, just to show you that you can. You have y must be greater or equal to x. Notice that I brought the x over and I ended up with the following. And if I bring the 2x over here, I end up with y must be greater than negative 2x. And so there you have it. Two examples on how to find the domain of a two-variable function.